All right, this time we're going to try to interpret why the conversion of a solid to a liquid, or a liquid to a gas, or a solid to a gas is endothermic. That's what we said before, right? That's a known fact. So the way you interpret that at the atomic level is to say this. You say that the kinetic energy, if it's endothermic, then that means you have to supply heat, right? And so that energy, heat is just a transfer of kinetic energy by random collision. So there must be a transfer from the atoms in the surroundings to the atoms of your solid or your liquid in order for them to transform. Okay, so for melting, vaporization, or sublimation to occur, you must be drawing energy from the surroundings. So kinetic energy of the atoms at the walls of the container, for example, or the stove that's in contact with your sample, kinetic energy from the atoms of those would have to be transferred. That's for it to be, if it's endothermic. Okay, we'll explain later why that's the case, but that would be at the most basic level. That would be the interpretation for that. So let's look at some examples about that we could explain with these ideas of energy being transferred. So why do you feel cold when you come in drenched from the rain? You get chills, right? So why do you feel cold? What happens when you come in wet? So you're wet, right? It's your skin. You got water here. What do the water molecules do? You dry out inside, right? As you dry out, your molecules leave, right? Going into from the liquid to the gas. It's an endothermic process, right? Liquid to gas, vaporization is endothermic. So where do the molecules get their energy from? From you, from your skin, right? And so you feel cold. You're losing energy to the molecules that are leaving your skin. Here's another example. Why is exposure to steam more dangerous than exposure to boiling water? Well, what happens here is your steam, your air molecule, your water molecules in steam, okay, when they get together to form liquid water on your skin, okay, steam becomes boiling water. And in order for steam to go into from a gas to turn into a liquid, that's exothermic, right? Exothermic means heat goes out. Where does the energy go to? Your body. Heat. And on top of that, you got the heat, plus you have boiling water still on your skin. And so what happens to the boiling water as it cools down? Cooling is also exothermic, right? So from boiling water at 100 degrees Celsius to your body temperature, which is 37 degrees Celsius, as the boiling water cools down to your body temperature, it releases even more heat. So steam is more dangerous. In fact, the condensation of the steam generates about 8 to 9 times more heat than just the boiling water alone cooling down to body temperature.